Good morning. Welcome back again. You are welcome in Sanjeevanee Mahavidyalaya Chapoli. This lecture number 3 is for B.Sc first year physics student. Same topic, mechanics, properties of matter. In last lecture we have seen about the measurement of viscosity by using capillary. First method we have seen, that is measurement of viscosity of a fluid by using capillary. This in detail I will discuss with you. Actually, this is not in our syllabus of this current year, of this academic year. But even though you should know what are the types of methods of measuring the viscosity. So this one is capillary method. Here fluid is poured, and here start, stop marks are observed, and then T2 minus T1 time is to be taken. Volume of the liquid is measured V. Length of the entire tube, capillary, is measured. G known to us here. Time is nothing but this difference. R radius of the tube is known this, and here is nothing but I have already told you the mean hydrostatic head of the tube. Now another measure of the viscosity is the viscosity measurement. Another way is what? Rotational method. And these viscometers gives the value of the dynamic viscosity. Rotational method is used for dynamic. Previous one, it is used for what? Kinematic. Here dynamic viscosity is to be measured using this rotational method. It is based on the principle that fluid whose viscosity is being measured is shared between two surfaces. Actually, this method is also not included in your syllabus of this year, but you should know the another rotational method is there. That's why I'm telling to you. Then, what about viscosity? In these viscometers, one of the surfaces is stationary, one surface is constant, remains stationary, rest, and the other surface is rotated by an external drive, and the fluid fills the space between them. The measurements are conducted by applying either a constant torque and the changes in the speed of rotation, or applying a constant speed by measuring the changes in torque. There are two main types of viscometers, or rotating cylinder and cone plate viscometers. So rotating cylindrical viscometer is like this. Here inner cylinder, outer cylinder, rotating it is. Then pointer is shown here. Fluid sample is taken here. Whenever the one is fixed and another one is rotated, the fluid gets mixed, separated, and by using this method we can find out the kinematic viscosity. Wherein is the dynamic viscosity. This is not in our syllabus, even though I am telling to you what are the types of measuring the methods of measuring the viscometer. And third viscometer is what? Cone on plate viscometer. This is next. Here also 3m alpha cos square alpha. What is this? Yes, by using this you can obtain the dynamic viscosity. So these are the three viscometers, three types of viscometers. Now let's discuss the important concept that either effect of temperature, pressure on viscosity of the fluid, or viscosity remains constant. What happens? We shall see in detail now. We shall see now effects of temperature. Where? Effects of temperature on viscosity of the fluid. See, the viscosity of the liquid decreases with increase in temperature. Simply you see, as if suppose X1 is the eta 1 is the viscosity of the liquid at normal temperature, and if its temperature is raised and the viscosity changes, suppose it is eta 2, then surely eta 1 is greater than eta 2, viscosity decreases. This is in case of fluids. In case of liquids, but there is a contradiction in case of gases. What happens in gases? The viscosity of gases increases with the increase in temperature. Fluids viscosity decreases and gases viscosity increases. Very interesting. This you very easily you can remember. Here liquids decreases and gases increases. I'll show you its graphical nature. Graphically I'll show you so that you can easily understand. Liquid decreases, gases increases. You remember. Liquids decreases with increase in temperature. This temperature 0 degree, 10 degree, 20 degree x-axis is taken temperature. Along y-axis it is taken its kinematic viscosity. And here yellow color you see, it is what? Oil. Oil means liquid. In case of liquid, what happens? Already I have told you. In case of liquids, decreases with increase in temperature. Temperature is raised, viscosity decreases. See, when your temperature is 0, this viscosity is near 2000 meters square per second, near about 2000. But as we increase temperature 10, 20, for 20 you see it is near to 100, 30 less than 100, 40 degree it is more than 10, and for 60 it is near to 10, 70 degree. I mean temperature increases, density is what, viscosity is what, decreasing. In case of what? Fuel. If we take water example, water is shown by orange color. Here it is like this. Here at 0 degree Celsius, its viscosity is more than 1. But as the temperature increases 0, 10, 20, 30, 60, here it is graph is shown. Here what? Viscosity is decreasing, and at 100 degrees Celsius, its viscosity becomes what? Less than 1, means near about 0.5. Now let us turn towards gases. This is helium gas, shown by which color? This color. Helium gas. Hydrogen you take. This is faint blue. From 0 to 100, suppose temperature is increased, its viscosity is going to increase. Now if you take mercury, you know it is in liquid form. So such a fluid which are liquids, their viscosity is going to decrease as the temperature increases. Now we take air. Air is nothing but the gaseous fluid. So here, as the temperature increases, its viscosity is going to increase. From this graph or graphical representation shows that whatever may be the fluids which are in gaseous form, their viscosity increases as there is increase in temperature. And in case of liquid fluids, their viscosity, instead of increasing, it decreases with the increase in temperature. So in this way you easily remember the effects of temperature on the viscosity of the fluids. The fluid may be liquid, fluid may be in gaseous form. Yes, in this graph we have seen. Now what we have seen, in short, we say that as temperature increases in case of gaseous fluids, its viscosity increases, and in case of liquid fluids, viscosity decreases. The lubricant oil viscosity at a specific temperature can either be calculated from the viscosity temperature equation are obtained from the viscosity temperature at ASTM chart. In this way, viscosity temperature equations we can obtain. Actually, this is also not for your syllabus, but for your knowledge point of view, I am going to tell you in short. Reynolds, this float, this, etc. Variability are the constants. Now, most important is what? What about the effect of pressure or on the viscosity? Effect of temperature on viscosity of the fluid we have seen. Now, what is the effect of pressure on viscosity of the fluid? Lubricants viscosity increases with pressure. See, whenever there is a more pressure, there is more viscous. For most lubricants, this effect is considerably largest than the other effects. When the pressure is significantly above the atmospheric pressure, the Bohr's equation Np is equal to N naught E raised to alpha phi, where Np is the viscosity at pressure P and N naught is the atmospheric viscosity and alpha is the pressure viscosity coefficient, which can be obtained by plotting the natural logarithmic dynamic viscosity versus pressure. The slope of the graph is alpha and P is what? The pressure of the concern. Here it is taken pressure and it is here taken what? The viscosity. Pressure increases, viscosity is going to increase. This graphical representation shows as the pressure is increased, the corresponding there is increase in the viscosity sensitivity. Selection of lubricants for various purposes. The question arises why viscosity is measured. We have seen measurement of viscosity is very important for various applications. Mostly all of you know that oil is utilized in the engine of the vehicles, maybe two-wheeler, maybe four-wheeler, maybe cycle. I mean, its applications are there in the for the engines of the four-wheeler, two-wheeler, whatever. Oil is utilized as a lubricant in the machines. That's why a selection of lubricants for various purposes is very important. First point is that one can choose an optimum range of viscosity for engine oil. For high load and also for speed orientation of speed operation, high viscous lubricant is required. In order to obtain the speed, high viscous lubricants are required. Next one is in pumping operation. Application is what? Pumping operation. For high viscous fluid, high power will require. For low viscous fluid, low power will require. It means if we take power into consideration, low power, low viscous, high power, high viscous. In making of blend fuel, less viscous fuel easy to mix, and in the operation of coating and printing also we utilize fuels. Then important concept from this chapter is that it is in our syllabus, included in our syllabus, that is that laminar flow, or it is also said to be streamline flow of the liquid or fluid. What is streamline flow? What is laminar flow? What is turbulent flow? All these things we shall discuss in next lecture number 4, where we can easily obtain the difference between laminar flow and the turbulence flow. We can see. So remaining matter we shall see in details in next lecture.